Assalamualaikum and selamat sejahtera. My name is NURUL Izzati HASYIMAH binti ZAINAL ABDIN from Faculty Science and Mathematics D 2019 10888281. Let me introduce you with my group mates.
Hi, my name is SITI Izzati binti AZMI with the metric numbers of D 201910888260.
Hi, my name is NADIRA binti MUHAMAD ZAILANI. Metric number is D 2019-10888250.
Hi, my name is SULIZA ALIANA binti MUHAMAD with the metric number D 201910888326.
In this video, we will introducing about infinite limits, limit of polynomial as x approaches infinity, limit of radical as x approaches infinity, limit of rational as x approaches infinity, and limits of exponent as x approaches infinity. But before we go further, let me explain a little bit about limits. So limit is basically just a prediction of what y value we should get at a point.
So I will give you an example. Limits of fx as x approaching to 1 is equal to 2. So from the graph, we can say that the fx as x approaching to 1 is 2 because y equal to fx. We have to check both sides of x approaching to 1, and if both sides give the same value, so the limit is exists. From the left hand side, from the graph, as x approaching to 1, the graph is increasing or approaching to 2, so the equal is 2. And the right hand side, we can see that as x approaching to 1, the graph is increasing and the value is 2. So we can say that the limit is exists.
Limit at infinite. If the values of fx eventually get as close as we like to a number L as x increases without bound, then we write if the values of fx eventually get as close as we like to a number L as x decreases without bound, then we write the end behavior of polynomial matches the end behavior of its highest degree. Here is some example for you to understand the limit of polynomial. The limit as x approaching infinity, 2x power of 4 minus x squared minus 8x. We can't simply substitute infinity into x because it is wrong. So how should we evaluate this? First, you need to find the highest power of x. And from this equation, 2x power of 4 is the highest power among all of it. Then you just ignore the rest of the equation and substitute infinity to 2x power of 4. So the answer is positive infinity. Then the second question, lim as x approaching negative infinity, negative 5x power of 5 plus 3x power of 3. Find the highest degree and substitute negative infinity into negative 5 power of 5. Then we will get positive infinity.
So next, here is the most common type of limits at infinity, which is rational expression. Rational just meaning in the form of one polynomial over another polynomial. There's a shortcut for this type based on the degree of the numerator and the degree of the denominator. In order to use the shortcut way, all you need to do is to compare the degree of the numerator and the degree of the denominator to find what the limit should be. So, what is degree? Degree is just means that the highest power that appears. So, you can use a shortcut to find the limit by comparing the degree of the top and the degree of the bottom in your rational expression. However, I will still show you the formal algebra way of finding it, but this is really useful shortcut. We go to the first case. So, in this example, the degree of the numerator would be 2 and the degree of the denominator would be 3. Those are the numbers that you are comparing. So, because the degree of the numerator 2 is less than the degree of the denominator 3, the limit will be equal to 0. Basically, because this function is bottom heavy, as the higher power is on bottom than on top, the rule is that the limit will end up being 0. The reason is that if you just look at the leading terms, the lowest power on top, x squared, and the highest power on bottom, x cubed, the overall form of this expression is 1 over x. It is because x squared over x cubed, this would be simplified to 1 over x. Is the overall form of it, and if x became very large at infinity, like 1 over infinity or 1 over a very large number, is basically 0 will become the limit. This is true even when x is approaching negative or positive infinity. The rule still can apply because even if you put in a huge negative number at x, means 1 over a huge negative number is approaching 0, it just means that it approaching 0 only from the other side. That's why this case will still hold. Next, we go to the second case. If the degree of the numerator is the same as the degree of the denominator, just like in these examples, where the degree on top is 2 from x squared, the degree on the bottom is also 2 from x squared. If they are equal, then to find the limit, the fastest way is to take the ratio of the leading coefficient. So write the fraction or the ratio that is the leading constants out front of the highest power terms. From these examples, because of the degrees are equal and is balanced in that way, you can just focus on the leading terms. So here there is 2x squared and 8x squared. Now we have the limit as x approaches negative infinity of 2x squared over 8x squared. We can just simplify this with algebra. Those x squared is cancelled. So we have 2 over 8, which of course can be simplified to 1 over 4. So your limit of the rational expression is the actual finite number, 1 over 4. Notice that because of the degrees are balanced, because it's the same, 2x squared on the top and bottom. So those x squared are dropped out, can be cancelled out. This would be true even if you had x cubed at the top on bottom, or x at the top and bottom. So because of that, it never mattered that x was approaching negative infinity instead of positive infinity. We only care about the ratio of those leading constants, those leading numbers out front. So as a rule in shortcut, no matter x is approaching positive or negative infinity, when the degrees are equal, you can just write a ratio, a fraction of the leading terms, and it becomes the leading coefficients that matter to find your limit value. Next, what if the degree of your numerator is greater than the degree of the denominator? So, in this example, x has a degree of 2 and x has a degree of 1 in the denominator. Since 2 is larger than 1, well, your limit will either be positive or negative infinity depending on your leading terms. So, let's say that you want to find the limit as x approaches positive infinity of this expression. You will only need to consider the leading terms. So, we can write the limit as x approaching infinity of 3x squared over x, and then you will need to use algebra to simplify and get down to the simplest x expression you can get. So as you can see, simplifying this expression gives you the limit of 3x as x approaches infinity. As you know from earlier examples, as x approaches infinity, something like 3x will also approach infinity. In that case, your limit was positive infinity. So, as a rule, you will just need to use the leading terms, write the ratio, and take the limit of whatever simplified x expression you can get in the end. I would say that it could be infinity or negative infinity depending on your rational expression. So those are the three main cases for finding the limit with shortcut. Now let me show you the formal algebra official way of finding limits of a rational expression real quick, just so you can see where this all come from. Basically, the algebra official way of finding the limit of a rational expression is to use algebra. What you need to do is by dividing each term that appears by the highest power of x that appears in the denominator. Back to the first case, for example. So the highest power that appears in the denominator is x cubed. So you can find a value for your limit, an actual number, by dividing all of these terms by x cubed. After we divide each of the terms, of course, we can simplify the expressions. And the magic of that is now, if you think of putting a number like infinity in for x, anything with an x in the denominator would go to 0, because any number that you know over something like infinity is essentially become 0. So for large values of x, each of these terms get arbitrarily close to 0, super close to 0 for all the limits, so that you can zero them out. To make it easier, if you see anything with the x power in the bottom and just number on top, it will goes to 0. So we simplify it and then we get 0 over 2, which of course bring to the value of 0. It goes the same for the second case. As the highest power that appears in the denominator is x squared, we divide each terms with x squared. Then we will got this. As usual, anything with the x power in the bottom, we can zero them out, bring us to 2 over 8, and simplify the expression, then we get 1 over 4. So that is the answer. Proceed to the third case example before this. We do the same step again by divide each terms with the highest power in the denominator, which in this example is x. Bring us to this expression with 3x minus 2x over x in the numerator and x over x plus 5 over x in the denominator. Zero out anything with the power of 3, then we got the answer for 3x, and as x approaching infinity, the final answer will become positive infinity.
Okay, I will explain to you all about limit at infinity involving radicals. In this video, we are going to evaluate the following limits at infinity. Let's get started. From this example 1, we can see that the limit of x approaching positive infinity. So, the numerator also goes to infinity and the denominator goes to infinity. So, we have a form infinity over infinity, and that can call indeterminate form. 3 in evaluating this limit is we need to divide the numerator and denominator by the highest power of x in the denominator. So in this case, we only have x raised to 1. So what we are going to do is to divide numerator and denominator by x, so that we have a limit x plus 5x squared over x, then all over 2x minus 1 all over x. Next, we have to simplify that radical. We know that x goes to infinity is positive. We can replace x by square root of x squared. Therefore, we can write our numerator as limit as x approach infinity of the square root of x plus 5x squared over x squared and all over 2x over x minus 1 over x. Now the limit is clear by x goes to 0, so that 1 over x goes to 0, and therefore this limit equal to square root of 5 over 2. Next, the second method is rationalization. When the limit of a function that has radical expression is an indeterminate form, we have to rationalize either the numerator or denominator by multiplying the suitable conjugate. In this example, limit of this expression square root 25x squared plus x and minus 5x multiplied with its conjugate. So the conjugate is square root 25x squared plus x plus 5x over the same expression. So this equal to limit x approach the infinity, the product numerator is 25x squared plus x minus 25x squared over square root 25x squared plus x plus 5x. Then we can simplify the numerator x over square root of 25x squared plus x plus 5x. Now this limit is in the form infinity over infinity, and we can do again divide the numerator and denominator by the highest power of x in denominator, but also consider the radical symbol. In this case, the highest of power of x is square root x squared, which equal to x. So we are going to divide the numerator and denominator by x. That is the same thing as multiplying the numerator and denominator by 1 over x. So we got 1 over square root 25x squared plus x over x squared plus 5, and we can write the radical limit x approaching of infinity 1 over square root 25 plus 1 over x plus 5. The x gives infinity, so the x goes to 0. So the limit just equal to 1 over 5 plus 5 equal to 1 over 10. Now, this expression as x goes to negative infinity, we can see that the highest degree square root 25x squared is goes infinity, and the negative 5x is the large number that gives the number of infinity. And this form is not indeterminate because the value is increased without bound, and this limit is infinity.
What is an exponential function? An exponential function is a function of the form fx equal to a to the x, where the constant a is known as the base, while the variable x is known as the exponent. So we can conclude that an exponential function has a variable in the exponent. Now, one thing that I want to make a note before we get started into this question is how the graph of e to the x looks like. The graph of e to the x basically looks like this. The limit as x approaches to the positive infinity of e to the x, the y value approaching to the positive infinity. Then, the limit as x approaches to negative infinity of e to the x, the y value approaches to 0. So, we are going to use these two results here for the next question.
We're gonna go through with 3 examples so you can master in this topic. So, let's try with examples 1. What is the limit as x approaches to infinity for the function of e to the x divided by 2x? First, let's see if we can use direct substitution. So, what is e to the infinity? E to a very large number is going to be a large number. So, it is infinity. For infinity multiplied by 2 is also infinity. So this is what we have here. It is an indeterminate form, which means that we can use L'Hopital's rule to figure this out. So what we're gonna do is, for L'Hopital's rule, we're going to take the derivative of the numerator and the derivative of denominator separately. What is the derivative of e to the x? The derivative of e to the x is simply e to the x, and the derivative of 2x is 2. See, notice that we no longer have the indeterminate form. So, if we replace x with infinity, the answer is infinity divided by 2, which will be infinity. So, that's the final answer. So, we move to examples 2 over here. Okay, limit as x approaches to negative infinity of 2e to the 2x minus 5e to the x divided by 3e to the 2x minus 9e to the negative 2x. Okay, notice that we have a negative exponents now to deal with. So, to review exponents law, if I have negative exponent by the base to negative exponents, that's the same as that same base to a positive exponent, but we brought the exponent down. So, we could apply the same rule here. Okay, let's ignore this first. So, we will have 9e to the negative 2x. Right. This e to the negative 2x we just brought down to the denominator. Okay, notice that this whole thing is going to go towards 0 as well. Constant over infinity is 0. Besides, there's the limits of as x approaches to negative infinity of e to the x. As we know, the limit as x approaches to negative infinity of e to the x, that's going to be 0 as well. Remember that there's horizontal asymptote on the left side. Okay, as x goes toward negative infinity, this 5e to the x is going to go toward 0. So 5 times 0 equal to 0. Right, what we are going to end up are having this fx going toward limit as x approaches to negative infinity of 2e to the 2x divided by 3e to the 2x. Okay, we figured that those e to the 2x will cancel out, so we will be left with 2 over 3. Okay, the last question is limit of x approaches to infinity of 1 plus e to the x divided by 1 minus 3e to the x. In this case, we have to divide the equation by e to the x, like we did when numerator and denominator had polynomial function. As we know, limit of x approaches to infinity of 1 over e to the x becomes infinity. So, 1 over infinity, that means very small, it becomes 0. Okay, so the answer is negative 1 over 3.